Hey, how's it going, guys? So here we are back for the Python BACnet Stacks Playground. Um, this is kind of like evolving a little bit here, but I think I may actually. So we already are doing this final project, and I may actually just revise this, maybe touch a little bit of this, and then also there is a new Python or Rusty BACnet GitHub. There is a new Python project. It's not even on here yet, but I might do actually a week of this. There's a new BACnet stack in Rust that has Python bindings. So maybe like we'll actually do that a little bit. I might do a little less of the Linux and Wireshark stuff and just do Python stacks. So this is kind of evolving. Apologize. So, but we are up to checkpoints 1 and 2, where we have the BACnet read write release null and back 0 and back pipes. Then also the apps that collect data CSV file and CSV format on BACnet read multiple. And then also right now we're doing our mini web server. So our last video was we were putting the mini web server together, and I don't think we did the day 22 theory lecture, so I'm probably way behind on this theory lecture stuff. So this is our AI generated course content to practice Python computer science theory, which is really good. I think that when AI writes a bunch of code for you, that you kind of know what it's doing, and then how to redirect it when it writes crappy code. I think it's important. Okay, so if we just look, so currently our web weather app so we went to OpenWeatherMap API. Just create a login for yourself, and I demonstrated how to get an API key. So it takes like a couple hours, I remember this. So you just walk through how to get an API key, and then it's free, and OpenWeatherMap will mail it to you or email it to you, and then you can delete it and everything like that, so which I still have to do here. So yeah, create a login, get your OpenWeatherMap key, and then I'm using let's see, so we are on just the 2.5 version 2.5 of the API. So if you get the API key, just make sure if you copy this code, just use 2.5. There is another there's another API, the 3.0, which is one call, which is kind of cool. So this will give you current data and historical data and a bunch of other hourly stuff. So I think that's 3.0. So but the code might be different how you call it. So just be aware of that. And ChatGPT is also really good at writing the code on how to do that. So if you remember like what we talked about, we used the requests library as a get. So that's a HTTP request, like opening up a web browser is a get. Then there's a get and post, which are most popular. So we could even do this. I think we could go, so I'm going to change directory vibe code app 4, I think, and just do Python OpenWeatherMap tester. So that just checked Chicago, and then see this URL, that's this. So I think in theory, so like we talked about F strings, and it's injecting our API key and everything, in reference to the last video and how we set up the .env file. That is to protect our stuff from not getting pushed to the internet for API keys. And then I still have to delete this from YouTube. Like I shouldn't keep putting my API key out on the internet on YouTube, but I'll just delete this, and it's just for demo purposes so people can know what they are doing. So when you get your OpenWeatherMap API key, you just paste it in here like mine is. but the point I wanted to do is like this tester file, like we should be able to just even paste this right into the browser, I think, because it's a get. Like all browsers do a get request. So I think in theory we should be able to just do this. Ta-da! Okay, so this is, you get the same data. So like our browser is doing the same thing as our Python script, and then our Python script is actually grabbing this JSON data and then packaging it into BACnet objects. And then we also are calculating a dew point from a function created by AI. So like, yeah, there's so much here. So there's even description. So this is our temperature, 33. So our Python script for BACnet object is only using temperature dry bulb and then also humidity, and then we're manually calculating dew point just because it doesn't have this. But there's a lot more other data here that you could also expose to BACnet object if you so choose. So if we go to our BACnet scan tool, like we've done a zillion times on all these YouTube videos, alright, so here's our web weather station where we ran it with our correct arguments, if you remember. So our relative humidity should be in the 90s, 92, and our dry bulb temperature 37.33. So if you Google weather, that's exactly what you're reading from this Google. Even though like we're getting data from OpenWeatherMap API, this could be the very same weather station at some airport in Chicago. I don't know. So like the point is like more than likely this weather is much more accurate, hopefully, than the local flimsy building automation sensor, where those sensors are very notorious for being very installed in very poor places, where the sun shines on them and then they read all erroneous values. They're cheap sensors to begin with, and I've seen so much stuff affect the building automation temperature sensor readings, where like the garbage truck pulls up next door to the building and the exhaust causes, you know, this to go up to 50 something degrees, and then all of a sudden mechanical systems are trying to use free cooling, or the boiler's running and the chiller's running because they have really crappy outside air temperature references. So the point is this app is kind of, I think it would be kind of cool if more buildings had outside air from the web. Sometimes it is built into the building automation system. Like when I used Niagara, they had a service for a time for the web weather, but it was always broken and it would break and it was never reliable very long term. So why not make your own? So like if I was doing this on a building automation system, I would link this up as some priority in the priority array, which we talked about. So like you could do your, if you were writing a point, let's say your air handling unit controller required networked outside air temperature, you could write web weather at priority 12, and then local building automation weather, local sensor weather at priority 13, where if this weather fails, then we default to the next lowest priority sensor, or the local sensor, where there should be some kind of failure mechanism built into this. Like if this web weather goes bad, if it's like if we put this point in here in our code for our this was everything, including our dew point function, which we covered before, where I think it did, then how we defined our web weather points, which we did on the last one. And then if there's a failure in the weather, AI automatically knew how to put this in, which we should simulate this. you see something that I think this is supposed to be inactive or inactive. Maybe Backpipes handles this behind the scenes, but we could simulate this later. Oh no, it is actually in here. So yeah, so like if web weather fails in our get request, which is just like we did through the browser, if that fails, like the internet goes down or OpenWeatherMap goes down, this BACnet point will go false. So that is another thing you could do on the building automation side, is just have an if-else block. If this is false, web weather is not okay, then you can relink to local building automation temperature for the building. So just to play around with it and test it. Let me know what you guys think. I think this is kind of fun. I think the next thing that maybe we'll get into is we'll do like a mini, so this will be our BACnet server. So we could do a little calendar schedule. So we'll make a BACnet server that just mimics an object for a building automation schedule. So that's a schedule point in BACnet, and we'll cover that next. But now I think I need to catch up on some of these script lessons. So this looks kind of suspicious, like I did this one already. But I was checking the YouTube video and so whatever, maybe we'll just have to start with this again, working with nested data, random numbers, and math, which I swear we covered before too. But alright, this should be pretty basic stuff. So let's try and get through this. So look, we're already on week 4, but I'm like way behind on these. So I think I should be all the way up to, let's see, so if we do one more week of, let's see, so I want to do like 5 days on just the Rust BACnet stack. So maybe through here we should start doing Rust, and then maybe a couple of days in here we should do a point discovery. So maybe we're not too bad. Okay, so we're kind of winging it here. So working with nested data, let's just get this, and then I know for sure we've done our theory lecture for today, and tomorrow will be theory lecture 23. Okay, so working with nested data, the goal is to manage nested data, which we'll get into this nested data stuff more in our BACnet applications, because we'll have to loop through data. Learn to manage nested data in dictionaries by iterating through nested data. Gosh, I could have swore I've done this. I think it's pretty self-explanatory. There's a list. Remember the list data structure. Then this is a dictionary with curly brackets, and then there's more data inside the list. So nested data structures, which we've seen in our BACnet application code. All right, so this is, see if we can just plow through this. Seems awfully suspicious here that I had this on my code. So maybe I did do this already. Python script lesson. Huh. We must have done this already. So this is our script lesson for, I just checking the YouTube videos, I didn't recall seeing it, but it looks like we did do this. So I think it's pretty self-explanatory. We just loop through data structures, and then we just pull out information. It's good practicing. This is a really important concept. So let's just jump ahead to day 23. Okay, so more of the random function, which I swear more of the math stuff, which we've already covered earlier. Write a program simulating, oh yeah, this is where we're at. Write a program that simulates, okay, so this is where the stuff gets hard in Python. So if we do this might be kind of tough. Okay, so I have a couple minutes and we're okay on time here. Write a program that simulates rolling a 6-sided dice 100 times. So, okay, so I think we wanted to import random package. So that's built into Python. You don't have to pip install it like we did before. And then we could do, I think you do like 6-sided die, I'm just gonna call it, equals random. Gosh, how would I think I can define, let's Google it. Python random integer values ranges 1 through 6. Okay, random int. Let's just do this. Which even though it's a dice roll. Perfect. Exactly what we need. So if we do, we could even do for I in range 5 times. Cover the range loop. We could just see what it looks like. So let's just do Python script lesson. So yep. So okay. So there we go. So this is 6 rolls of the dice. We got a 6, a 2, a 2, a 3, and a 3. All right. One thing that's kind of interesting, and it goes up way above beyond this topic in my pay grade, is like if you go to the mathematics of random, I've seen this before, getting off on the weeds here. Machine Learning Mastery, which I used to follow this guy's blog, random numbers. So this is like, if you're a PhD mathematician, like a computer science person like Jason Brownlee, there's many different ways that you calculate random numbers, which I didn't know that. I just thought like random numbers is just random numbers, but to the mathematician, oh no, there's several different ways that you can calculate random numbers. Okay, so just thought I'd throw that out there. Write a program simulates two-sided dice 100 times. Okay, so then to roll two 6-sided dice. Okay, so if we wanted to do 100 dice rolls, so that would be 100 of them. And then write a program that simulates rolling two 6-sided dice 100 times, and count how many times the sum is greater than 7. Okay, so if we do, okay, so we would do 1 dice roll 1, and then we'd want to do dice roll 2, and then we would say like a sum of rolls equals 0, and then we would just say sum of the rolls equals that plus that, and then we could say is greater than 7. Let me think. We could just say 0. So we do this outside of the range loop, and then the range loop would count it upward. Okay, so we would say then if sum of the rolls is greater than 7, count this upwards, equals plus plus equals 1. And then I think we could print this baby at the end. See what this looks like. 40, 39, 41, 53. I think we're doing it right. Kind of fun. I think if you get into like more advanced computer science, like master's degree level, which I've read some tutorials, you would get into the probability of dice rolls and all that kind of stuff and get into machine learning. Okay, use the math square root to compute the distance between 2 points. Oh boy. Entered by the user. I don't know how to do that. Maybe we'll save that one for later. Create a list of 10 random integers from to 100 and sort it using sort. That should be easy. Create a list of 10 random integers. So we would just say data equals a list. And then we could say, gosh, you could even say that you could do like the list iteration for I in range. You could do it right in here too. And I might just do outside of that though. That's more advanced Python program. For I in range, create a list of 10 random numbers. 10 random integers. Okay, so we did, crap, what did we do? Python random. It was, okay, so we want ours to be between 1 and 100 for I in range. Import random again. Create a list of 10 random integers between 1 and 100 and sort it. So we just want to do data.append random number. And we just say print data. And I think we can do print sorted data. There, see that? So we just have some random data here. It's not sorted from lowest to highest. And then this built-in function to Python sorts it. I think if we get into more easy computer science algorithms, we'll manually sort it. Until then, that's what we'd have to do. So pretty cool. That has Python has random and the sorted function built into it. Although this is one I don't know how to do. Is this reminds me of like vector math or something. What do they do here? MathNet? Use MathNet to compute the distance between 2 points. I don't know this one, so I'm just gonna make a tutorial, not entire answer. See what that says. AI mode. Math square root. Understand the formula is derived from Pythagorean theorem. Alright, so it wants us to do Pythagorean theorem. I guess I can't remember, it's been too long. right, so if we do, it's almost tempting just to cheat and just say we did this one. Let's just study it and call it good. Good enough for us. So here we go. This is just the distance. I'm sure if I dusted off my math lessons, I could probably understand this a little bit better, but I can cheat with a little bit of artificial intelligence. Calculating the distance. All right, well, maybe that's good enough for us. I might call it a day, but I think that is all I'm going to do today, guys. So if you're enjoying the series, hoping you're liking it, tomorrow we will get into doing the BACnet schedule object on backpipes. So, and I think we might call it a day on our weather app. So more to come. Talk to you guys later. Hope you're having a great day.